Here are a couple of gas law problems that I like to go over. But before we do that, let's review quickly which gas laws that you need to know. So the first one I would recommend that you remember is the combined gas law, which is P1V1 over T1 is equal to P2V2 over T2. So this combined gas law pretty much covers all the first three gas laws we went over. So if you have this one, any of those three gas law, we can figure it out, and I will show you how that's done. With this combined gas law, we can assume sometimes, depending on the situation, that either pressure, volume, or temperature can be constant, or they can be all changing. Either way, you can use this gas law. So definitely know this one. And if everything is changing, including moles, the second gas law that you need to know is PVs and RT. Okay, so let's look at the first question. A sample of a hydrogen gas at 1.50 atmosphere, constant volume, is heated from 0 degrees Celsius to 150 degrees Celsius. So it tells you the volume is constant, which means it's not changing. What will be the final pressure of the gas in atmosphere? So as I mentioned before, anytime you are solving gas law problems, you need to label it, because from there you can figure out what gas law you will be using. So I'm just recording or writing down what they tell us in the problem. So temperature must be in Kelvin for all the gas laws. So I'm going to go ahead and already convert that. And then they are looking for the final pressure, so that will be P2. I don't know what that is. I'm going to solve that. And I'm just going to go ahead and put units. Since it's given in ATM, I'm going to keep it as it is. And they also ask you in atmosphere. And temperature 2 went up from 0 to 150. So then we got to add 273 to this. So the new temperature, not new temperature, but the in Kelvin is going to be 423 Kelvin. All right. So then I'm going to go and write down the gas law. I'm not going to using the ideal gas law for this. They don't mention anything about the moles of the gas. So I'm gonna write down combined gas law. And from the question, I know volume is constant, which means that can be canceled and giving you P1 over T1 is equal to P2 over T2. So next step will be just putting in the actual values for each. I'm solving for P2. Okay, so then we have to solve for P2. What is P2? And just to mention, some of the gas law, depending on, which ones, like this one, I hope that pressure 2 is higher, because when you increase temperature, it should go up. Okay, so I hope it's greater than 1.5 atm. And let's go ahead and do the math. So I'm going to do P2 times 273. So that's 273 P2. This unit should cancel because it will divide once you do that. And then 1.5 times 423 is going to be 634.5. This is in pressure, so ATM. Solving for P2. So lastly, you got to do 634.5 divided by 273. I get 2.32 atm. Number 2, what will be the volume occupied by 2.5 moles of nitrogen gas? So I'm given 2.5 moles nitrogen gas exerting pressure is 1.75 atm at temperature 475 Kelvin. It's given in Kelvin, so I don't have to do anything. So looking at this, I'm looking for volume. Okay, so looking at the value given, I'm thinking I gotta use ideal gas law, and I have to solve for V. So it's up to you how you want to do this. You can go and plug it in first and then solve for V, or you can go ahead and do this already. You want to solve for V, so I divide both sides by P. And then put the information on there. So when you plug it in, you should get 55.7 liters. Sorry, my pen stopped working at this point. So you plug it in, NS 2.5, R is 0.0821, temperature as 475, and then on the bottom you put 175 atm. And like I said, the final answer should be 55.7 liters.